Hi, welcome to the video solution for Edexcel Physics. This is Edexcel IAL Physics Unit 1 WPH11 new specification and the third video of the series. So let's start. Question number 16. Concrete is a material often used for building. A stress-strain graph for one type of concrete is shown. Positive value of a strain represent compression and negative value of a strain represent tension. So this is a stress and a strain. Okay, this is positive portion of the graph, a negative one which is all about compression, the positive region, and this is for tension. Explain how a stress strain graph shows that concrete is made or concrete is more suitable for use under compression than under tension. So the reason is, if you see the graph, and as strain is increasing, stresses keep increasing for the positive part. So maximum stress during compression can be around 40, like that. And if some tensile force is applied on the concrete, then maximum tensile stress is 10 million pascal or megapascal. So of course during compression, the maximum stress that can concrete withstand against the force, which is 40 megapascal or million pascal, and for tensile it can only withstand for 10 million pascal. So of course concrete is more suitable for compression rather than tension. So you can compare the maximum stress. Part B. Steel is a metal often used in building. The stress-strain graph for steel is shown. This is a stress-strain graph for steel. A steel rod has a diameter of 45 millimeter. Calculate the maximum force that could be applied to the steel rod before it fracture. So stress-strain graph is given and the diameter is given. We need to find the maximum force. So first of all, we need to find the maximum stress that can be applied. So the maximum stress that can be applied is this point. So you can take it maximum stress a little more than 5, I guess, not 5.1. I'm not going to take because it's I'm going to take it's around 5.02 or 5.03, something like that. So stress is 5.03 into 10 to the power 8. This is Pascal, and I need to find force F. Clearly I have a relation between stress and force. So stress is force per unit area, and F force is stress time area. Stress I found from the graph. Area is pi r square. So you can say stress as 5.03 into 10 to the power 8 into area pi r square. So pi is there, and r square, r is d by 2 because d is 45 millimeters. So 45 into 10 to the power minus 3, in order to convert into meter, divided by 2 whole square. So sigma pi r square. When you solve this right hand side for F from your calculator, so your answer will be equal to 79986.93. You can shift the decimal here and 7.9, and you can round it off till 8 into 10 to the power 1, 2, 3, 4, 5 Newton. So this is the maximum force that can be applied on the steel. To make concrete suitable for use under large force and under large forces, steel rods are sometimes embedded in concrete. An external tensile force is applied to the steel rods. Concrete is poured into a mold around the rods. Once the concrete has set, the external forces is removed from the steel rods, placing the concrete in compression. So, okay, this is the situation. Explain how this process increases the maximum tensile force that the concrete can withstand before fracture. So first you need to understand this whole situation, what is going on here. So before pouring concrete, there is an external tensile force due to which the steel rod, you can think the steel rod is, this is the steel rod original length, and if some tensile force is applied before pouring concrete, so the steel rod will be in tension, or there will be some amount of extension. So this is due to some tensile force, so there will be extension in steel before pouring concrete. And now if you are pouring concrete around this you know this steel rod, and then you wait for setting up the concrete to dry up. So when the concrete dried, you remove this external tensile force. So this steel rod go back to original shape and then compress the concrete around. So at original shape, this concrete is there after removing tensile force from steel. Now at that moment, the concrete is under compression. So this is the situation, normal situation. And now if some external force is applied on the concrete, some external tensile force is applied, then some of the tensile force first is going to take by this steel, because the concrete is already in compression, so that will improve the stability of the concrete. So that's how you can see this condition, and you can write like that. Explain why the external tensile force in the rod must not take the steel beyond its elastic limit. Clearly, if elastic limit is crossed, so steel rod will be permanently deformed. It will not go back to original shape. So the concrete will not be fully compressed, or will not be in compression. Question number 17. The velocity time graph for a car for the first part of a journey is shown. So okay, so velocity time graph, there are different situations: first gear, second gear, third gear, and the fourth gear. Okay. Part A, as the velocity of the car increases, the driver changed gear. Each change in gear produces a small decrease in velocity. State how the graph shows that in third gear, the car has a smaller acceleration than in the first gear. So in third gear is smaller acceleration than in the first gear. So we need to look for the graph again. So this is the graph. And if you compare the situation graph of the third gear and graph of the first gear, so this is velocity time graph, and gradient of velocity time graph gives us acceleration. And clearly during third gear, graph is less steeper than the first gear. So in first gear we have a more steepness, more gradient, or more acceleration, less steep, less gradient, or less acceleration. So that's how you can say that because of the less steepness in third gear, the car has a less acceleration. Part 2, determine the average acceleration when the car is accelerating in second gear. So again we need to find the acceleration, average acceleration in second gear. So we need to go back to the graph. So if you see here, this is the second gear and we need to find the average acceleration. So we need to find initial velocity when the second gear is applied. So this is the velocity here and this is the velocity when the gear is changed from second to third. So we need to find the value of this initial velocity u and the time, and u and the time, v and the time here. So the coordinate of this point is approximately the time is 4 second, comma, and velocity is 6.2 6.4. I'm taking 6.4, and for that the time is 10 point, okay, 10.1 before 1, 10.5, comma, velocity is 13.5. Okay, now I can find the acceleration. So acceleration is 13.5 minus 6.4 divided by 10.5 minus 4. That means 7.1, 5 minus 4, 7, 5 minus 4, 1, and okay, divided by 6.5. And then acceleration A2, if you say A2 is 1.09 ms minus 2, or you can round it off to 1.1 ms minus 2. So this is the acceleration of the car in second gear. Three, the equation that links the power P of the car engine to forward force F on the car and velocity V of the car is P equal to Fv. This is the formula for power in terms of velocity, P equal to Fv. Comments on the magnitude of F when the car is in higher gears, assuming P remains constant. So higher gears, you know that velocity is increasing. So if you see the equation, they say that the P is constant. If P is constant, that means force is inversely proportional to the velocity. So if velocity is increasing, then in order to make power constant, F has to decrease. So driving force has to decrease. So you can write this statement about this behavior or relation between velocity and force at constant power. The manufacturer of different car gives the following information. So first gear, second gear, third gear, and this is the maximum velocity in this first gear and the acceleration, maximum acceleration during first gear. And okay, so we have maximum velocity and maximum acceleration column in different gears. Calculate the minimum time taken for the car to accelerate from rest to 60 miles per hour. You may assume that time taken to change gear is negligible and 1 mile is equal to 1600 meter. So we need to find the total time taken by the car to accelerate from 0 to 60 mile an hour. 60 mile an hour. So first we need to convert the 60 mile into meter per second, because the velocities in tables are given meter per second, and 1 mile equal to 1600. So for 60 miles per hour, so 60 times 1600 divided by per hour, so 3600. And if you solve this is 26.7 meter second inverse. So the idea is we need to find the total time to accelerate from rest, meaning from velocity 0 to 26.7 meter per second. And we have a interval from 0 to 10, sorry, 0 to 18, and then 18 to 32. So first we are going to find the time interval to accelerate from 0 to 18 at this acceleration. So time is t1, and from 18 to 26.7, this is the time t2. So we are going to find t1 and t2, and sum of t1 and t2 will be the total time that is required in this question. So we know that a1, acceleration 1, is equal to v minus u upon t1. So a1 is 2.9 is equal to 18 minus 0 divided by t1, and from here if you cross multiply with for t1, so t1 would be equal to 6.21 second. Similarly, for a2 is again same formula, instead t1, so v minus u for second interval, and t2 for second interval acceleration is 1.2, final velocity is 26.7 minus initial velocity was 18 divided by t2, and you can figure out t2 is so t2 is 7.25 second. So total time t is t1 plus t2, which is equal to 13.5 second. This is the total time for the car to accelerate from rest to 60 mile per hour or 26.7 meter per second. Explain why there will be a maximum speed at which the car can travel. Clearly, if you see you have a straight road and the car or some object or car whatever is traveling in any direction. So if the car is traveling in any direction with the velocity v and it is increasing continuously, it is increasing velocity. So this car is experiencing many types of frictional forces. Air resistance is there, so drag force or air resistance and frictional forces are also there. So we have a drag forces and we have a driving forces, and this drag force is depends on the velocity. So if velocity increases, drag force keeps increasing. Drag force or drag forces, you can include friction and friction between tire and the road and air resistance. So as velocity increases, drag force is increasing until driving force driving force balances all the drag forces. At that moment, unbalanced force is zero, so velocity cannot increase more than a particular value because there is no net force. So there is a maximum velocity at that moment that cannot be increased. Thank you very much. Have a nice time. May God bless you.